All right, everyone, this is the lecture entitled the. Well, she doesn't have a title for this one. Anyway, well, we went over a lot of history in this one and the how to read and do math with the periodic table and elements in the periodic table and what all these numbers mean. This is going to be a long one, so bear with me, but hopefully it's fun and you'll be able to remember some of the things that we need to remember. First is how we read these things. This is the symbol of an element. The number in the top left is the mass number, and it tells you it's neutrons plus protons. Okay, this number can change. This is the atomic number, and this is how many protons there are. So you can easily do math to see how many neutrons there are by subtracting these two. This doesn't change as long as this doesn't change, because this identifies the element. This number over here is the charge. Okay, this will tell you how many electrons there are compared to protons. So if this says 2 negative, that means that this ion has a negative charge, which means there's more electrons because they're negatively charged than there are protons. So from this, you can assume that there's 84 electrons in this element. Something to note about charge is Coulomb's law. It is that the strength, conceptual idea about Coulomb's law is the strength of the charge depends on a couple things. First, the magnitude of the charges. So the pole between them depends on the magnitude of their charge and also the distance between them. So kind of think about gravity. You know, like the bigger planet has the bigger pole, and the further you are away from that planet, the less it pulls. Kind of same way with charge, but it's not size of, mass. It's size of charge. So think about it that way. Okay, that's that section. Note the change in mass number are different isotopes. So up here, if that changes and this doesn't change, that means it's just a different isotope. Different charge other than neutral is an ion. So if there's nothing here, that means that this is just a neutral atom, meaning it has no charge. If there is something up here, it is an ion and it does have charge. Okay, let's go over some fun stuff in the periodic table. Today we learned just the structure of it and the different groups and things. So I came up with fun things to remember, all this stuff that we need to remember. The first one is the worst one. I figured the worse it is, the better you'll remember it. So here we go. To remember that horizontally on the periodic table, those are periods. Just remember that a hor is going to have a lot of periods generally. Columns are groups or families. Just remember when I have to do group work or when my family is fighting, I want to bang my head against the column. The two big sections on the periodic table is there's the transition metals, and just think you're going from adolescence to almost puberty, and then the main group of elements is your main adolescence and your main section of puberty. Those are the ages. So you go from age 3 to 12, you're transitioning from adolescence to puberty, and then in adolescence from 1 to 2, you are in adolescence, and 13 to 18, you are going through puberty. Okay, I've got a fun little story. For this story, we're going to go to the periodic table on her slide. So give me one moment. Okay. Here we are here. So we need to remember all these things, so I came up with a little story. There's a dude named Hydrogen. And Hydrogen liked to hang around his friend Alkali. That's why he's always over there. And Alkali one day asked him, he said, "Hydrogen, are you an alkali metal?" And Hydrogen said, "Nah, Alka, you lying. Alkaline metals." And then our friend Hydrogen went through a rather lengthy for lanthanide transition, and he started going through puberty, and he got a lot of actinide or acne on his face. And so after his lengthy transition to have actinide, he reached puberty, and people kept telling him that gender was hollow for halogen. And he responded back, because he's a member of the Church of Jesus Christ of Latter-day Saints, and he said, nah, gender is noble. Hopefully that helps you remember. It helped me. So that's all the things we need to remember. And just also remember that metals are malleable, they're good conductors, things like that. Metalloids are like a mix between the two, and non-metals are like gases and liquids and things like that. Okay, now comes the history part. Note that she only asked us to remember the names and really discoveries of the people. That's what she's going to test us on, and she's probably going to ask us test questions on things that pertain to the things they discovered, what it means, or what their experiment means, or she'll give us an example experiment, and she's going to ask us, like, based off these results of the experiment, what can you conclude? And it's going to be based off like some of these experiments. So I'm going to try and go through these slow enough for you to understand, but quick enough to get the video to be shorter. Okay, first, the Greeks believed in the 4 elements. And so Avatar there, 4 elements, earth, air, fire, water, all that stuff. And then alchemists, if any of you have read the book The Alchemist, it's pretty fun. And they try to turn lead into gold for, who knows how long. Who knows if it's even possible. I should look it up. First one to be the pessimistic chemist, or I don't think it's pessimistic chemist. I think it's some other word. Anyway, Boyle, Robert Boyle. Boyle had a boil on his face and popped the 4 elements idea. He came up with that there are atoms, or he believed that things were made up of atoms, made of smaller parts, or atoms. Then came along Antoine Lavoisier. His law that he made was so famous that they decided to name it after him, of law. Lavoisier, I don't even think I'm saying it right, but law helps me remember. And he came up with the law of conservation of matter, that matter cannot be destroyed or created. Then came around Joseph Proust for proportion, Proust proportion, and he came up with definite proportion. I guess you can think about Joseph was definitely a prophet, and Proust is a proportion, so you have a definite proportion. Matter has the same compounds and structures from anywhere. So, like, he took water from anywhere, and he discovered that there's always the same proportion of hydrogen and oxygen in water. Then we have John Dalton. So John Dalton came up with multiple proportions. And when I think about this, I think, let's see, John Dalton, who else has the initials of JD? Well, Johnny Depp, and he plays multiple movies and has multiple acting methods, I guess. And I just imagine Johnny Depp saying, in like a crazy Jack Sparrow voice, matter is made of atoms. And people think he's crazy. That's my weakest one, I promise. Then we got J.J. Thomson, and his cathode formed a J, and that's probably why they named him J.J. And he found out that cathodes were made of electrons. So I guess he discovered that there are such things as electrons. And so then it came along Robert Millikan and Harvey Fletcher. And Hurricane Harvey really came in with a charge. And so these two found that electrons have a charge. Hurricane Harvey came in with a charge. Then we have Marie Curie, and she's like, I'm the only girl on this list, so I'll sing radioactive. And then she's like, well, that singing voice is so bad that it's disintegrating my ears. That's what she discovered radioactivity, and that they're disintegrating elements, basically. Then it came along Ernest Rutherford, and sometimes people who drive a Ford go the wrong way, just like these alpha particles. And so he discovered nucleus by that one experiment when he was shooting alpha particles, and some of them bounced back or went a different direction than he was assuming. And so he discovered a nucleus, and also that there are protons, because alpha particles are positively charged, and for them to be repelled, there's a positive going against a positive. Then there's James Chadwick, and you know who was really a Chad? Jimmy Neutron was a Chad. He discovered neutrons. So that's all the history that she gave us in this lesson. Hopefully you can remember all those. This was fun. Thanks for listening.